On some Netezza systems, tables have columns numbering 300 of these. Those are wide tables. What the issue is that you might have a wide table with hundreds of columns, and yet the users are only querying the first 4 or 8 of those. This is an excellent time to create what is called a materialized view. As you can see here, our original table, I just put 12 columns in there for you. But most users are only querying the first 4 of those, so I created a materialized view that's just going to take those 4 columns. Users can query either of these tables, and the optimizer will decide the best one to query. You see, when it's moving those big 12 column blocks in, it's a lot of movement, especially if you're only reading 4 columns. So it's a fantastic option to have where the optimizer can just move in those 4, and things are going to be so much faster. We're going to learn everything there is to know about materialized views. Materialized views are beneficial for wide tables that contain many columns, between 50 and 500 columns, for example, where typical queries only reference a small subset of the columns. A materialized view is a thin version of the base table, and it contains a small subset of the most frequently used columns. The whole idea is to make queries faster. Materialized views are excellent when fast, single, or few row lookup operations are needed. These are called tactical queries because they generally come back in a second or 2. The thin materialized view is automatically substituted by the host optimizer for the base table, allowing faster response. Now, what's so interesting about this is you're querying the real base table, and it's the optimizer that says, I can satisfy that query with the materialized view, and I'm going to make that call. Queries can also be run directly against the materialized view if users know about them. Materialized view data slices are co-located on the same SPUs as the corresponding base table. This is called SPU local. Think of it as they have the same distribution key. Materialized views are automatically updated with the base table on all insert, update, and delete operations. In other words, when you change something in the base, add something to the base, automatically the materialized view is also changed accordingly. Above, I've got the syntax for you, and I've got an excellent example here in yellow. Create materialized view, you've got to give that a name. As select these 3 columns only from this table, and I want it ordered by this column. If you don't put the order by in, it's going to have the same order as the base table. And remember, it's always got the same distribution key as the base. But now, when users query this table and they just want those 3 columns, or just one of those 3, or 2 of those 3, the optimizer is actually going to just say, they said to do it from this table, I'll do it from the materialized view because it's so much less block movement. And users actually have the ability, if they know the name of that table, or that view I mean, it's going to be able to query that directly. And I've never seen that before in any other system. This is how you change a materialized view. You say create or replace. In this case, I gave it an order by statement. And that's how you can add things to it, take things away from it. You're actually replacing that previous materialized view.
This lesson brought to you by Coffing Data Warehousing. Need to learn SQL for Netezza, Teradata, or Aster? Visit coffingdw.com for our helpful training guides. With Teratom, SQL stands for So Quickly Learned.
Hi, this is Tom Coffing. Thank you so much for watching the video. Please hit subscribe to make sure you are kept up to date on all our videos.